I'm also here, but I'll wait.
And you're ready to go. Start whenever. Enjoy your session.
Thank you. Hello, everyone. Welcome to the next session. As you know, cryptox is in the real world, and in the real world, there are humans, and humans have a lot to do, and there is more to humans. There is also a law background and a social background. And in this session, we will explore some of these aspects. We have two excellent talks. And the first speaker is Katarina, and because we're on a schedule, I'm not going to say much more. Katarina, take it away.
Thank you very much. So I will just share my screen and hope that everything works properly. And I really hope that you can see my slides.
We can, yes.
Oh, perfect. Thank you very much. All right, so I'm Katharina Krompholz. I'm a faculty at the CISPA Helmholtz Center for Information Security in Saarbrücken in Germany. Can you? Yeah, okay, perfect. So sorry, multiple screens, everything's new. Yeah, so my name is Katharina Krompholz. I lead the Usable Security Research Group at CISPA, and I really love interdisciplinary work, and I really love building bridges. So I would really like to use the next 10 minutes to raise awareness for some of my work, which is actually human-centric and focuses on how users interact with security protocols and tools. So ultimately, behind every security vulnerability, there stands at least one little human that made a mistake. And actually, if we look at the transition between a concept that we can prove in theoretical research and a product that actually is then out there in the society and that people interact with, there are many, many other humans involved. So we have cryptographers at the more theoretical end of the spectrum, and maybe protocol designers and API designers. And then we have software developers, administrators, system integrators, and some decision makers. And then really at the very practical end of the spectrum, we have the poor end user, who is usually a non-tech savvy person who wants to do their best and who wants to make the right decision, but doesn't really know how to do that. So how can we now understand the needs of all these users? And well, the answer that I can give you from my human-centric perspective is empirical methods. So what we really must do is we must talk to them, and we must, more important, listen to them. So when I was a grad student some time ago, I was really curious about where all these vulnerabilities in TLS come from. So I thought it would be a good thing to do a user study. So my idea was, let's find out why there are so many vulnerable HTTPS configurations out there in the wild. Well, we knew that at that time because we had studies based on internet-wide scans that suggested that many of the configurations out there were actually vulnerable at that time. So the idea that we had was to do just an experiment on the usability of configuring HTTPS. Just to give you some more information about myself, I'm a computer science person, so everything comes from a computer science background. So I also slowly started to adapt these more social sciencey methods, empirical methods, to expand my methodological toolkit and to explore this human-centric perspective. So what we did back then is we conducted an experiment where we just let tech-savvy people who were really knowledgeable in this domain, configure HTTPS. So we gave them a scenario and we told them, well, this is what you have to do. We collected the bash and the browser history. And then along with all this information, we implemented a think aloud protocol. So we instructed the participants to think aloud, and we had an experimenter sitting next to them who was taking notes and wrote down everything they said or they did. And then also whenever we get consent, we also recorded these people. So we have some audio and video material, a really large stack of handwritten notes. And then of course we had all these virtual machine images and the bash and the browser history. And then when we looked at the data, we saw, well, there are some typical mistakes that those people make when configuring the protocol. And we saw that actually the type of mistakes that the people in our study made were actually corresponding to what we can find out there in the wild and what has been shown by previous studies. But the more interesting things, at least from my perspective, were the findings from the audio tracks. So not the things that we can see on the virtual machine images or in the technical evaluation, but more the things that the people said. So these findings are actually really striking, because what we found was that these people were incapable of making informed security decisions most of the time. So even those who then ended up with really good configurations of the protocol, they just managed to do that because they found the right sources online. They just followed the right tutorials. And we also really identified some severe misconceptions about some protocol components. So for example, what cipher suites are used for, and things like that. And then we also found some really interesting statements, like one participant said, "I'm afraid of using crypto." And the other one said, "I have no idea what I'm actually doing," which I think is pretty concerning. And this was also the reason why I was motivated to look a little bit deeper into why this problem is there and why this transition from a really nice protocol, a theoretically nice protocol, doesn't really work so much when we want to transfer it to practice or to real configurations to really secure the internet ecosystem. So then we decided to really look at the exact mental models that people have of these security tools and protocols. So what is a mental model? A mental model is nothing else than just a mental representation of the world that surrounds us humans. And parts of these mental representations can be nature, it can be everyday things like this glass, it can be other things that I interact with, like my iPad or my computer, and also it could be actually a protocol that I'm interacting with. So everything has some mental image. I have a mental image of almost everything that I interact with in my head. So the question is now, how can we measure these mental models? How can we get them out of the users' heads? The complicated matter here is that very often a lot of this knowledge is not explicit. So when we ask humans, they don't immediately tell us what they understand, because a lot of the knowledge is actually tacit knowledge that users cannot easily articulate. So before talking about how we can measure this, just briefly a summary of the studies that we did. So we did 2 mental model studies where we wanted to measure these mental models. One was on HTTPS. We had administrators and end users, real administrators and end users. And also we had a study on mental models of Bitcoin, Ethereum, or cryptocurrencies in general, also with a actually broad participant pool. And so what we found, and what was the reoccurring theme here, was that there are always misconceptions about security benefits, about protocol components. When we talk about HTTPS or the study of HTTPS, we have a lot of distrust in the user interface or in the security indicators that people get, and a lot of confusion. So some participants, for example, completely confused encryption and authentication, which I think is also particularly worrisome if this comes from a tech-savvy person. And then when we look at the mental models of cryptocurrencies, we have a lot of misconceptions about key management, anonymity, and Bitcoin fees. And I think that also here, the key management part is the concerning part, because this is really an open problem, and this is a problem that creates a lot of additional burden to users, regardless of whether they're experts or non-tech-savvy end users. So let's talk a little bit about the methodology, how such studies can be done. So first of all, we collect data, then we look for patterns, and then we develop a theory. So again, I will spare you the detail, but I would like to just give you some brief examples how exactly these steps can be performed. So usually, at least my studies are based on qualitative data. And this is actually also what most other people do that research mental models of technical things, whatever they might be. So for example, we use interviews, observations. Sometimes we let participants draw something, or we give them some card sorting tasks. And as you can see, here are some examples. Actually, those are both examples from the studies that I just talked about HTTPS and cryptocurrencies. So we have this huge pile of drawings along with the audio track, video and audio material, and then sometimes we have photographs of the results from these card sorting tasks, where we let people use some terminology from the protocol and let them find the connections between them. So this data that we then have is unstructured data, so we have to somehow make it structured, right? And we do this using coding. This is a term that is from social sciences, and this just refers to the process of making unstructured data structured. So we can do this offline with pen and paper, but sometimes we do it online. It really just depends on the type of data that we have. And the common goal is that we want to construct a theory, a model. So then in the end, how can such a mental model look like? Well, again, here I will not go very much into detail, but just to give you an overview. So what we can see here, this is the best case mental model of HTTPS. So all the good things that we got from our participants just combined. And what we can see here is that this is actually very sparse mental model, which does not really correspond to the technical reality. So for example, a lot of buzzwords are mentioned, but we're not really able to explain what they were about or why they are there. Then, well, some participants knew that there was a certificate authority involved, but it was completely disconnected from the rest. So those mental models are really sparse. And then we also had a worst case mental model, which has some really strange assumptions, so to say. So for example, some people assume that there is a centralized encryption entity that encrypts all the traffic that gets sent via HTTPS and so on and so forth. So you see, it's really very much different than the technical reality. So why are these mental models like that? Well, we first need to understand how design and mental models are connected to each other. So we found in both of our studies that actually the mental models were very much driven by the user interfaces or by the components that people interact with. So for example, administrators, mental models were very heavily shaped by some specific protocol components. And in the cryptocurrency study, we found that there was actually a significant tool bias. So people very much, so the mental models were heavily shaped by the tools that people used to manage their digital assets. So there's a really a strong interplay between mental models and design. And what we need to do, well, overall, we want to have technically sound decisions, right? And we first of all need to make sure that design informs mental models in a way that these are at least functionally correct or functionally sound. And then on the other hand, we need to adjust the design to the actually sparse and wrong mental models to still help users to make the right decisions. And what I would like to use to raise awareness for is that all APIs, all command line interfaces, and all metaphors that we use in our designs shape mental models of any of the people along the spectrum from theory to practice. So whatever command line interface a software developer or an administrator interacts with, or whatever API has an impact on the mental model that this person will create about the protocol. So I would like to raise awareness for the fact that we should stop making implicit assumptions about our users and really start listening to them a little bit more. And this holds even if they're experts. And then we need to design security technology that is better tied to the needs and values of their users. So I'm already at the end. Here is just a brief list of some references for those who are interested in some of the papers related to what I just talked about. And now I'm very happy to take questions.
Thank you very much, Katarina. We have a couple of questions. A very practical one. Mashir asks, how many users do you have in your study?
Yes, in our studies, well, usually because those are qualitative studies, we have a smaller number of participants. So both of these studies were about 30 people. We are not really interested in quantifying a phenomenon when we do these studies. We really are interested in constructing a theory that we can then use to build some hypothesis that we can then test with statistics and then find causal links and quantify. So usually here a smaller number of participants is enough. Usually we recruit participants until we reach saturation, which means that we don't hear anything new, no new themes emerge.
Thank you. More questions. Martin asks on Zulip, in case you want to go later on and try to find more things. How do we know that human is the right level of abstractions and that psychology is the right tool for understanding? So why don't we use employees and the social situation? Why don't we use another level of abstraction instead of focusing on people? But maybe you're actually already doing that abstraction because you talk about developers.
Yes, so I think that this is a really, really excellent question because this is an ongoing debate in our community. This is a debate that we should also have furthermore. So, well, yes, we focus on individual users, and already the concept of a user is the concept that was somehow introduced by people who develop technology. And yes, we need to look beyond the user. So I would say that in this particular line of work, we are already in the infancy. So looking at users is one of the first things that we do. Some years ago, people only looked at end users. Then we slowly started looking at the more like expert type of users, like administrators and developer. And now the question is, where else do we go? So I think we should go more towards theory and look more at these types of humans that are involved in this chain. But yes, we also need it at other systems like organizations and the society as a whole. I think there are really exciting new research areas out there that still needs to be explored.
Good. So one question from Kimberly, looking at the future. What do you think should be the role of human factors work, like the studies that you do, in the decision-making process for crypto standards?
I think this is a really excellent question. I think that, well, my personal opinion is I think that this is a line of work, or this is a perspective that should be considered, because we can really see and we can actually measure that this is a component that is important to really understand why we have so many security vulnerabilities out there in software or in protocol configurations. So I wish that this perspective is incorporated and that people who do interdisciplinary research are also involved in the decision-making process when it comes to standardization. But I know that it's a very complex thing. So I know that this is not easy, and I know that we are running into a state explosion probably if we look at so many aspects.
And I just have time for one last question, so I'm going to peek with my power of being the chair. Sanjit asked, is it necessary for end users to understand the underlying crypto? Shouldn't the browsers automatically take care of this? This is an excellent question.
Yes, this is a really excellent question. I'm sorry for being too fast with the answer. I totally agree. So if we look at this slide, actually, so I think that we should really not focus so much on the end user, because why should the end user know things? I mean, this is like a lot of burden that we put on end users. So what usually happens is that whenever someone more on the theoretical end of the spectrum or more on the like software development side doesn't really know what to do, then the decision is immediately shifted to the other person in the chain, which is then in the end sometimes the end user. And I think we should really move away from that. So I also like to talk about umbrella conservation. I don't know if this term is familiar to you. It's a term from biology where marine biologists say that we need to protect the bigger species in order to protect the smaller ones. And I think a similar concept should apply here. So in order to protect the end users, we should already start protecting the administrators, the decision makers, and the software developers and maybe designers. I think that's the right way to go.
So thank you very much. Sadly, we don't have time for more questions, but you have plenty of them in Zulip if you want to go there and take care of them. Thank you very much, Katarina. Big applause for you. And if I may ask Sarah to come up and share her slides.
Yep, I'm working on it now. All right, let's move this out of the way. Oh wait, did that work? Can you see?
Yeah, we can see, but we don't see full screen. And now we see full screen.
All right, great. I'm missing the little green box, so it's hard to tell. But okay, great. So my name is Sarah Scheffler. I'm a fifth-year PhD student in cryptography at Boston University. I'm going to be talking today about compelled decryption in the US. So this is when courts compel people to decrypt their own devices using their passcode. All right. So I had a whole introduction to this written using cases from lower courts, but then last Thursday there was an important development, which is that a petition was filed to bring Andrews v. State of New Jersey to the Supreme Court. So the facts are that a gentleman named Andrews had an encrypted device. He was directed to reveal the passcodes necessary to decrypt the device to the courts, or else face contempt of court. So Andrews pled the Fifth and claimed that complying with this order would violate his Fifth Amendment right against self-incrimination. So this case is not unique. There are a whole host of these cases in the lower courts in the US, and their decisions are all over the map. Most of these actually ask a slightly different question, which is whether you can be forced to enter your password, or even just provide the decrypted contents of the device rather than to reveal the passcode itself. So today I'm going to describe how we use cryptography to investigate what the law says about these kinds of compelled actions. So if you think you might end up being an expert witness in one of these cases, I hope this analysis is helpful. And also as part of this analysis, I'm going to try to bring this into context with the rest of the crypto wars. So this work is part of a broad and growing field of research that investigates the interplay between law and cryptography. So we're interested in a two-way street here. So one, what are the legal implications of using cryptography? And two, how can we use cryptography to understand the law? In the context of compelled decryption, we'll answer the second question first. So we'll model the doctrine that is used to compel decryption using cryptographic simulation. And then we'll use that model to better understand the first question of whether somebody can be compelled by the court to decrypt their device. So I apologize, our exact model really only applies in the US, but the way we approached this should also apply to analyzing the laws of other countries. Okay, so to do this, I'll have to give a bit of background on the Fifth Amendment of the US Constitution, as well as the definition of testimony. So in the US, the Fifth Amendment includes the privilege against self-incrimination, but this privilege is not complete. It only covers certain kinds of actions. One of the restrictions is that it only covers actions that are testimonial. So essentially, testimonial actions are those that reveal the contents of your own mind. And this could take a couple different forms. The first way an action might be testimony is if the output of the action directly reveals the contents of your mind. So if you're forced to write down how you committed a crime, that's pure testimony, and that's almost always covered by the Fifth Amendment, meaning you do not have to comply. Additionally, an action can be protected even if the output of the action is not testimonial, but it's possible to infer something about your beliefs based on how you perform the action. So for instance, let's suppose the government subpoenas you to produce a gun if you have one. Your response to the subpoena implicitly testifies as to whether or not you have a gun, and that implicit testimony is still protected under the Fifth Amendment. But there is one additional layer of subtlety, which is that the government can compel an action anyway if its implicit testimonial aspects are a so-called foregone conclusion, meaning they add little or nothing to the government's existing knowledge. So in my gun example, if the government already knew you had a gun, now they can likely subpoena you to produce it, and that's likely no longer protected under the Fifth Amendment, because even though the action has implicit testimony, namely whether or not you have a gun, it's implicit testimony that the government already knew. That last part is called the foregone conclusion doctrine. So this doctrine originated in the context of forcing people to comply with subpoenas for paper documents that the government already knew about. Like people would just refuse to comply with subpoenas for tax documents. And now it's being used to compel decryption. And importantly, the contents of the documents produced are usually not protected by the Fifth Amendment. Only the act of production of those documents has some kind of testimony inherent to it that is protected. So if we drill down, the core question is the act of using the password to produce decrypted documents a foregone conclusion? Or does that act reveal something new and testimonial to the sum total of the government's information? The courts have not determined a single answer for this. The key question that they can't agree on is what testimonial information is leaked by that act of production. So some courts say that the only implicit testimony when entering a password is the fact that the defendant knows the password. Others say that if a password is being used to produce documents, then something must be known about the documents themselves that are being produced. So in order to try to analyze this question further, we're going to model this whole process cryptographically and create a formal definition for the foregone conclusion doctrine. So the key insight here is that the definition of the foregone conclusion, namely that the testimony adds little or nothing to the government's knowledge, is actually very similar in style to cryptographic simulation. So in our model, the government will be required to create a simulator in the crypto sense to simulate the compelled action. And we do this in a way that the government will not need to simulate any non-testimonial results of the action, such as the contents of the device. So we have a compelled action, C. The respondent wants to show that the compelled action inherently discloses some contents of their mind. The government claims that it already knows all of the testimonial information leaked by the compelled action. So the idea here is that if the government is right, that the act of production did not rely on the contents of the respondent's mind, then they ought to be able to simulate the compelled action using everything in the world except the contents of the respondent's mind. So we take the world and we split it into two parts. the respondent's mind, and everything else, which we call nature. So the compelled action can query both parts of the world. The simulator can only query nature. And the idea is that if the simulator is able to produce a result that is computationally indistinguishable from the compelled action's result, then we will say that that compelled action was a foregone conclusion. So the next question is, what determines nature? So, right, the government might not know in advance whether a certain document exists or not. So we allow the respondent to equivocate and set the contents of the world, so both its own mind and also nature, ahead of time. And this will give the respondent the power to ensure that the government can't compel it to reveal, any secret documents if it didn't already know about them in advance. And the government simulator should work for all settings of nature and the respondent's mind that are allowed by the evidence, right? So if the government knows that the respondent has a gun, the respondent should not be able to equivocate to a world where it doesn't have one. So this is our definition. We say that compelled action C is a foregone conclusion with respect to the simulator and the evidence if for all settings of the world allowed by the evidence, C and sim are computationally indistinguishable. And I'll say that to test this definition, we encoded a dozen of the most important non-encryption related foregone conclusion cases into this framework, and we made sure that we got the same result as the courts on all of these various cases. The encryption cases are sort of too all over the place to make a reliable benchmark. So now we can apply this model to compelled decryption. So the scenario is that there is a phone or a laptop in nature at a known location, encrypted with a password that is held only in the respondent's mind. So this definition finds that decryption is generally not compellable because decryption generally cannot be simulated. And for the same reason, this also applies to similar types of cryptographic operations. So decommitments, hash preimages, and that sort of thing. But there are certain circumstances in which the government could simulate the result. So first of all, sometimes there is testimony from another witness as to the contents of the device, right? So essentially this means that the simulator can produce the result directly using the evidence and doesn't need to work too hard to simulate the compelled action at all. So in our opinion, that should allow compelling decryption of those specific files where there's testimony about them, but not the entire device. Another consequence of this definition is that it composes with the rest of the crypto wars in a way that is quite bad for privacy. So there have been some suggestions for things like a law enforcement key or a manufacturer key or a device key or whatever that would allow the police or the courts or Apple or Google or whoever to decrypt phones as long as they possess them physically. So our definition says that if such a key existed, it would actually make the compelled decryption question a foregone conclusion, and then the respondent would be compelled to decrypt the phone. So it's even worse than it sort of sounds. The existence of this law enforcement key would would create a simulator, which would make the result a foregone conclusion because the simulator would work. And that would make the respondent themselves forced to decrypt the device themselves rather than using the key itself. And then last, there are a lot of things we do that bolster security overall that actually leave one more vulnerable to this particular threat of being compelled by the government to reveal secrets. So the security community has been trying for a long time, for very good reason, to get rid of passwords. But it actually seems like there's something very special about passwords against this specific threat. So with that in mind, we also wrote a security definition that captures when a protocol defends against this threat. So up until now, we've been thinking about whether or not a respondent can be compelled to do a current action based on the things she's done in the past. And now I want to ask the question, let's suppose I just want to go about my daily life and run crypto protocols. I think there's a fire alarm going on, but I'm just going to keep going. Is the act of running those protocols opening me up to being compelled to do an action about my secrets in the future? So we call being secure against these attacks FC resilient. And let me point out that this FC resilience definition is interesting, even if we pick a different definition of the foregone conclusion doctrine itself. So in our paper, we talk about FC resilience for several different primitives, including MPC, and we provide a construction and code for a 2PC protocol that achieves FC resilience for one party. So fortunately, with this alarm going on, I'm at the end. For additional details, I'm happy to chat with you. Email is probably the best way to reach me, but I did manage to log into the Zulip chat so I can also hang around there. Any
Yeah,
questions?
and at this point, I think you should react to the alarm. Questions are in Zulip, but we're really concerned about your safety. So probably you should follow. You're muted.
Yeah, fortunately I only had about a minute left, but I think I'll respect the fire alarm and try to get the heck out of here for a little bit. I apologize.
Please, people, put the questions in Zulip so that she can come back and answer the question. Thank you so much, Sarah. We hope nothing is bad and see you live soon. Okay, and with this, we're more on time than what we expected for very unfortunate reasons. So thank you very much for sticking to the session, even if we were a bit late. Put your questions on Zulip so that Sarah can reply when she comes back. And now please take a break for more crypto.